Welcome to our Telemetry Pipeline webinar. This is Sibel Yılmaz. I am working as fractional CMO in Kron Technology, and today we will take you through the details of our very important product Telemetry Pipeline together with my colleague Yalım Közer. First, I want to take you through some brief information about our company, Kron Technologies. Then I will hand over to Yalım to give more information about product, and also he will take you through a kind of short demonstration about the product properties. So let me summarize Kron at a glance. Kron Technology is a global cybersecurity software vendor specialized in identity and data security, and all R&D and all products and solutions are based in Turkey. Kron Technology is listed in Istanbul Stock Exchange, Borsa Istanbul, since 2011. Last year, especially, Kron Technology had showed a strong growth in terms of revenue as well. So there was 31% growth, year-over-year growth, and we are proud about these results. And when we look about the details of this revenue, 30% of this number is coming from international markets. And when we look also to customer portfolio and also the regions that we have been covering, so it is mostly distributed. And in the next page, I will take you through the map and the customer penetration in order to give a little bit more insight. Also, you can see from the map, so we have throughout 35 countries more than 400 customers, and also I will show in following pages as well. So according to Gartner Peer Insight, the score that we received from our install base is 4.8 out of 5. Therefore, also we are proud about these results. When we go back to map again, Yalım, I want to take you through, through the number of employees. We have 175 in total, and we have penetration in 8 countries in terms of employees coverage as well. And in total, Kron Technology had in cybersecurity market 19 years experience. Therefore, we have long history briefly. And on top of that, we are proud about recognition that we received from very important analyst firms. And of course, everyone knows that Gartner is #1. And also, we have included in Forrester and Omdia reports. On top of that, in Gartner, as I mentioned, in terms of customer satisfaction and customer feedback, we received very good score. And also, I can tell you in terms of the customer penetration and customer references, we have very good penetration and very happy customers, because our especially support services are very strong. And when we look about the analyst firms recently, we are proud for another recognition as well. As you all know, KuppingerCole is very important, especially for Europe. And they recognized PAM solution of Kron Technology as a leader in 3 different categories. And the first one, in terms of PAM results, it is very, very recent in 2026. And you see from the graph, we are in leader quadrant with very important players. On top of that, in non-human identity management and also in OT and ICS, we recognized as a leader. Therefore, also we are proud about this result. Before I hand over to Yalım, I want to take you through the product categories. So, as I mentioned, the first #1, identity and access management in terms of product category. And the second one, in the right-hand side, we have very important telecom solutions install base. And the third one that we will take you through today is data security and data management category. Under this category, we have database access management and telemetry pipeline solution. Now, I want to hand over to Yalım to give more information about telemetry pipeline, and also what I can briefly, before I hand over, if you have any questions, please write in the question, let's say, text box. And when we complete the session, we want to answer the questions that you will send us. Thank you very much.
Thank you, Sibel Hanım. Sorry, Mr. Sibel, just how we say it in Turkish, excuse me. Today, I'm going to be talking about our telemetry pipeline, but before that, let me briefly tell you about myself. I've been working for Kron for almost 7 years right now, and I've been the product owner of this telemetry pipeline product for almost 3.5 years right now. So today I will be explaining what our product does, but before that, I would like to give some information about what it does actually solve, what is actually telemetry mean. I know everyone actually knows what is telemetry, but what are we focusing on? What are the challenges and problems in telemetry collection focused on security? And then how we can solve these problems with our telemetry pipeline. After that, I will be going through use cases and deployment options and the architecture. And I'm going to sum it up with some central management features, which is basically the UI and the control plane. And then I will show those features briefly so that you have a better idea. And at the end, I will try to take your questions and try to answer them. So let's dive into it. The first question, what is telemetry? Telemetry is a really generic concept. It is the automated process of collecting data from distributed systems and then analyzing it and like searching different stuff in it. So it's a really generic term. It can be coming from IoT, etc. But today we will be focusing on four types of telemetry. First of all, the logs. These four types can be shortened with an acronym, which is MELT. It symbolizes metric, events, logs, and traces. But in the security domain, logs and events are more common, so we will be focusing on those two more. The logs are infrastructure and security, errors and the activity, user activity, application activity, the infrastructure activity. All of these can be considered as logs, and these come in different formats, which I will dive into that more in detail in later slides. And then there are events, which symbolizes the configuration changes, security modification, and usage information. And the metrics are important bandwidth, CPU, and throughput, like those kind of important metrics. And basically what differentiates them from logs and events that they have a standard format for time series databases. So they can recognize these kind of data directly. And then there are traces, as you all know, these for distributed request paths for microservices, so that you can keep track of what's happening on each step one by one. These can be all processed through our product, and we will be focusing on these four, but of course, telemetry is a huge concept, but this is what we mean with telemetry when we say telemetry pipeline. And the first problem, why it keeps growing. And we all know, we hear about it, it's going to be much more in the coming years. And so what's driving the growth? That's the question here. First of all, the security needs are, and the security logs are growing rapidly. The companies use different solutions on different locations, on different architectures, and they generate different kind of logs without any standards. And then there are the cloud native infrastructures like Kubernetes and the microservices, which generates a lot more logs compared to monolithic applications. And then we are just integrating AI agents and agentic workflows to our life. And these are going to be much bigger compared to the previous ones. What I mean with bigger is that like the growth will be much bigger. So basically, we used to enter a prompt or click somewhere, and it used to create a single log. But now with these workflows and with these microservices technologies, when we click or when we enter a prompt, it generates probably 100 times the logs compared to the monolithic applications. And because of the audit and compliance needs, we have to save these logs, keep track of them, analyze them, which compensates the problem as well. So, but it's not just the volume. There are different problems as well. First being is the variety. There is no standard in the source side. Like the logs are coming in different formats, different protocols, and with different taxonomies. which means there is no standard, there is no naming standard. So when you have to integrate these logs to your systems, you have to go through a lot of parsing problems or protocol problems or integration problems. So this is the biggest second challenge. And then when you go through all of these problems and solve it in your company, you're probably going to solve it with a single vendor until now. And then when you do it with a single vendor, you don't want to go through all of these processes. So that makes you vendor locked in because you don't want to change those silos because they're integrated already. So how did we use to collect security telemetry? The legacy architecture was that there are some data sources, which you can see on the left, like agents collecting data from servers or different applications. There are the network and cloud infrastructure logs, authentication logs, IAM logs, firewall traffic logs, application logs, which like gives information about what's going on inside the application. And then there are database access logs and etc. And then there are stream storages like Kafka, where you might have to collect data from. And what we used to do is we would directly send them to a SIEM solution, and then we would collect them through the SIEM solutions collector, which was making the architecture locked in. Like you don't have any other options to send and route the data because these SIEM solutions mostly don't let you, or they have their own protocol in like encrypted protocols, etc. And then on the bottom in the parallel, what most companies does is that they implement their observability solution for collecting metrics and other stuff so that they can track what's going on in their infrastructure and the applications. And when the problems I mentioned before comes together with the architecture I just mentioned, it creates bigger problems. First of all, the license cost and indexing cost, which is CPU consumption and computing cost, the indexing. And then the licensing is based on event per second, and also it's based on CPU consumption. So if you want to like scale up to these growing numbers, you have to pay a lot more to catch up and scale to these logs. And then you have to keep the logs in shorter retention because the I/O rates of these analysis applications are really high, and those high I/O rate disks are really expensive. So you have to keep really short. You really have to keep the retention really short. So these all bring you to inefficient analysis in the end. And the variety creates the taxonomy problem, which you have to solve in the SIEM solution mostly. You have to create a standard, you have to parse according to that taxonomy. And then if you want to onboard new data types, then you have to go through all of those parsing problems, protocol problems, etc. And then, as I said already, if you do go through all of these processes, if you scale to these logs, and then if you solve the taxonomy problem, in the end, you become locked into that vendor. You cannot share that data, or if you want to share that data, you have to go through all of these processes. And what are the possible solutions for these volume, variety, and vendor problems? First of all, for the volume, you don't have to send all of your logs to your SIEM. You can do data tiering and reduce the low value data. Don't send it to your SIEM so that you don't have to keep it there. You can send it to a like much cheaper destination, much cheaper storage, so that like it costs less to store those logs. And then if you can collect the logs once and then you reuse it across every tool, like if there was a middleman that can distribute and route those logs to any destination and in the right way, in the right format, then this would also solve that problem. So you would have to install their agents once, and if you can get the logs to the middleman, then you can route it to anywhere you want. And if you use OCSF-like standards, that would mean when a new vendor comes or new integration is needed, mostly those analytical tools know these standards, so you don't have to go through the same parsing problem in each CM. You would do it in the middleman, and then you would send your data to the SIEMs, and then you do the normalization while the log passes through that middleman. So you won't need to do the parsing on each tool again and again. And then if you do all of these, you would create a vendor-independent collection. And how we do that, how we create that vendor-independent collection, we do it with the Kron Telemetry pipeline. How we do it is that normally there was, on the right, there was the collection part, there was the collection layer, but you can mitigate that and you won't need that anymore. You can just send all of your data to the middleman, which is us, like the gateway, and then you can do all of the things required here, like you can collect it, enrich it, transform it, and then normalize it, and then you can route it to the designated destinations, which would solve the coupling problem, and you would decouple your system, because if you need this data on a new system, then you wouldn't go through all of the collection part. We can send the same data to multiple destinations in the right format. And to be able to do this, it's really important to have support to integrate with all of the systems. On the left, you see some common sources, and on the right, you see some common destinations, but these are not all. We have more than 100 integration points, not just like push collecting. We can also do pull collecting to databases, to removed files, etc. And with this, like even if the application doesn't have a native integration to us, we can integrate with this application through the standard protocols like TCP, UDP, HTTP server, HTTP client, you name it. And then at this point, like we can collect from most of the sources, let's say, not any, and then we can send it to the required destination in the right way. And we can also do custom integrations. But what I mean with the native integration is that when it's natively integrated to our system, when we have the support for it, we have really custom parameters for it. Like you can really customize the process and how you want to collect it or how you want to push it with like specified parameters. It's not just collecting it. After you collect it, then there is the format problem that I mentioned because of the variety of the sources, which can be really hard to control. But what we do here is that, or at least what we think is the best for the use case is that when we collect all those different standards, we tell to the customer that it's really better to adapt a common schema like OCSF, ECS, OpenTelemetry, CEF, Leaf, SIM, like those kind of standards would, if those kind of standards, common schemas are implemented to the log while it passes, then, as I already mentioned before, you wouldn't need to do all the parsing again and again with different tools. You would just do it once in the middle, and then when you need a new vendor or new integration point, you just send it with the data in that common schema, so you wouldn't go through all of the processes I mentioned before. After you collect it, you change it to normalization, you made your normalization, and then it's not just about that. We can also apply different kind of functions to it in the order you like, of course, and you can create substreams, etc., which I will demonstrate later on. But on the left, you see the data reduction functions, and on the right, you see the transform functions. Data reductions, which explains itself, these are transforms for reducing the data volume, which are like filtering, sampling, deduplication, reducing, throttling, routing, field dropping, and flattening. Well, I will deep dive into some of these functions later on, so I won't keep it long here. But on the right, you see some other transform functions for different purposes, for maybe normalization, or maybe for enrichment, encryption, maybe security needs. It can all depend. We all, at this point, until this point, I mentioned different parts of the application. Now, how we can use these different like parts of the application together and create some use cases with these functions. So to start with the main security use case, this would be collecting the data, of course, and then parsing it, normalizing. And after that point, we can do enrichments based on file lookups. We can add some context to the data based on comparisons in the file, and then we can enrich the data according to the lookup, which can be really beneficial because normally what would happen is that you would send your data to the SIM, and then from there you would have to make some comparisons, and then you would have to like search for the data if it's on the threat list or if it's on the blacklist, and then it can take more time when you do it like that. But we can add this context to data while it passes through us in memory. And we can also mask the data if it's needed. Like if you don't want to send your sensitive data in the cloud or whatever might be the reason, you can do it with our masking function. You can mask basically anything and then route it to the designated destination. Also, what we see is that some companies are collecting all their data in the SIM, which is a really expensive tool in most cases. So we propose that if you do all of those data reduction functions on the data and then reduce the noise in it, like the low value data, if you reduce it at our product, you can send it to your SIEM, which is filtered data. You can send the data in a filtered way, and then you can send the raw data to an audit store so that you have all your data in a audit store, and you comply with the regulations, and you don't need to send all your data to the SIM. Moving on, you can add another tier so that you can send the really important data to the SIM, and then you can send the data that you normally query to a log management solution, and then you can send the full fidelity data to an audit solution, which create the data tiering. And then you would have to pay much less to your SIM solution, and you can divide your cost to the other solutions, and then you would pay less in the end. So basically, right telemetry should be in right format, and it should be stored in right tier with the right cost. This is what we propose. We also have a solution for the log management, which I just mentioned, where we do the queries. Here on the right, you can see our solution, Kron Data Store. This is a different kind of solution, but we would like to mention it here as well, because they can be together in bundle. Here we can scale up to petabytes, and then we can do 93% compressions, of course, based on the data. And then we can do really fast queries inside this data, so that's not a problem also. And we do it do this in a columnar data store, so it's really scalable and really fast. And then in Turkey, we do a lot of logging compliance for some important ISPs. So this is really field tested, so to say. And I mentioned you can store all of your data in the object storage, like an audit store, which is really cheap. But when you need it, and when you want to do a, let's say, investigation on the data from, let's say, 1 year ago, then you would have your data in an audit storage. But with our rehydration function, it's also called replay, you can select the objects you want to replay, and we can collect those data, and we can send them to our telemetry pipeline so that we can ship them to any destination you want to do the investigation on. And also, we cannot just collect it. And while we write it to the object storage, we have a thing called key prefix. And with that, we can divide the objects into different layers. First being is that, like, the most common way to use it would be you would normally divide it into years and then months and then maybe days. Even you can go smaller, but that is enough in most cases. And then what you would do is you can look inside the context of the log, and you can also divide it according to that. Like, you can create different objects based on the IP and other stuff, maybe the host, etc. So this is really beneficial when you need that log again. You wouldn't have to rehydrate all of the log. You can just select where you want to look, and like you can really specify which data you want to rehydrate to the other systems. In a different use case, if you want to migrate a new SIM solution, it's really easy with this solution, because normally I told you that you really have to go through all of those collection processes. But with this product, you can really connect a new SIM really easily. You can just do it with single or like a couple of clicks, let's say. And then if you want to migrate data from your old SIM, like if you're going to use a new SIM, Kron Telemetry pipeline can be beneficial again in this part. It can collect and put that old data into your new SIM, etc. And while you want to do a POC with a new vendor, you don't want to send your like critical information, so you can mask the data, as I already said. There are also we also have buffering function, which can be really beneficial in the upgrade processes, and also when the endpoint is down for any reason, we can buffer the data until the buffer is full, obviously, and then you can also select how the buffer should like act when it's full. But it's really configurable at that point. I want to deep dive into the reduce function. This is a function that I mentioned on the transform part. This is basically a data reduction function. What it does is that it merges different datas. What I mean with different is that you can put conditions and say, if these fields are the same, you can send the data, you can merge the data, and you can do it by conditions. You can, sorry, there's something going on. Anyways, sorry. You can merge the data based on the conditions you put. Like you can say that. To move on, I was just talking about the reduce function here. So what you do is that you set some conditions on the logs, and you say, if these fields are the same, and if you're doing, like if you want to send the data, sorry, I got my mind a bit distracted. Let me start over again. So there are logs incoming, and normally you just want to add some fields. Like if some fields are the same, you want to add them in your SIM. So normally, if you had 10 logs and if you ship them to your SIM, you would do that adding in that SIM solution. But with given conditions, if some fields are the same, like source port, like source IP, destination port, destination IP, let's say, and the event ID, if those are the same, you can merge these logs and add those fields in real time in memory, and you can send a really merged log into your SIM solution. And with doing that, you can really squish the log into like much less volume events, and you can get really big benefits out of it. In Turkey, by doing that, we saw we can, in big ISPs, in big traffics, we saw that you can reduce the log up to 90%. Of course, it depends on the log, but you can really reduce the log. Moving on to deployment options and the architecture. Here, we can, first of all, we have two different applications. First being the control plane, we call it central management system, and then it basically controls the workers, and workers are the data plane, and these data plane workers can be distributed to your needs. There's no limitation here, and these workers can run in different platforms as well, and then like from a single control plane, you can keep track of what's happening inside these workers. You can keep track of the logs. You can keep track of the EPS counts, like whatever you want to do, and you can have different configurations inside them. You can have the same configuration as well. It really depends what you want to do, and you can place these workers on different networks, and there wouldn't be any security problems as well by doing that. You wouldn't have to collect all these logs into a single place and then send them back to where they should go. You can really easily manage that. What's inside the central management system, which is basically our UI? We have different functions like live view, which is basically getting samples from the log. You can do simulation with these sampled logs, and you can like test your configuration without pushing it to the production. It's basically a sandbox, playground, whatever you can call it, and then you can simulate the process before you push that configuration to the production, so you don't lose any logs in the process. I already mentioned about the distributed processing, and as I told before, you can configure distributed workers from a single control plane. And then we also have version control and audit logging, because when someone changes something, you really want to know what has been changed. And if things go south with the version control, you can swap back to the working configuration really fast. And then another big problem is that if you push a wrong configuration to the worker, it might cause the worker to stop. So in this kind of collection application, it's really important to validate the configuration before it's sent to the worker so that it doesn't crash the worker. Moving on, we already mentioned about the parsing problem, but we also have a solution for that, because those parsers can be quite time-consuming, let's say, to create them. And then we have an LLM parser, which basically what it does is that, like, you give the log that is being collected, and then you give the format that you want this log to become, and then our parser would create you the required parsing. And then we can also do monitoring and alerting, like if the source and destination like goes down, or if they're not sending data for any reason, we can create alerts on them, and we can also keep track on what's going on with the monitoring features. And one of the biggest problems in these areas is that, like, the configuration part can be really challenging in these applications. So with our drag and drop UI, it's basically no code, and you can create easy managed pipelines, easy configured pipelines with our UI. And we also have a secret vault integration, so you don't have to put every password to us from the worker. We can connect to the secret vault and pull the secrets or the passwords and integrate with the destination that we want to send our logs. So I will be moving to our demo part before we get into questions and answers. In the demo part, I will be demonstrating how we build a basic pipeline, and then how we route the data, like, let's say if we're doing a storage tiering. So this is our UI. Here you can see a lot of different systems that we can integrate with some sources and destinations. And we also have TLS configuration, vault configuration, but for the demo purposes, I wanted to keep it basic. So we will be collecting some Fortinet firewall logs, and then we will be collecting them in UDP format, I mean the protocol, and then we will be decoding them with the incoming bytes. You can see other different parameters, but we won't be needing them in this case. And then we create our destinations, because later on in the next incoming part, we will connect these sources and destinations together, so that and we will implement the transformation functions as well. Here you can see different codecs, like you can send in different formats. In Splunk, you know, there are some, like if you want to send the message as raw text, you would have to select the raw endpoint, and if it's in JSON, then you select the event endpoint, and etc. There are some different like parameters that you have to enter, and let me pass this a bit. There are some buffering configuration as well, but for the demo purposes, this is basically it. And then moving on now, I'm configuring my S3, which is in this case, it's an object storage, which is located on-premise, because as you all know, most of the object storages are S3 compatible. It's basically the same API, so we can just do it from the UI. Moving on, also here you can see the key prefix feature. Here, year, month, day, and the host field is going to be our separation points. And there are some compressions options, a lot of different options that you can configure according to your needs. You can put some tags on the file names, etc. And then I will just create a basic file that I want to write to logs to different destinations. Now moving on to the pipeline section, I will be connecting these logs into, I will be connecting the source to the destination. So let me enter the find my source that I just created, and then I will be selecting my destinations here. Let me fast forward a bit. And you see on the left, I have the destinations, sorry, on the right, I have the destinations. And in the middle, I have the parser right now. I'm configuring the parser, which we already uploaded to our system. So it's ready to use. Now I will implement a routing function because I want to route the data to different destinations in different contexts. Like I want to filter it according to different contexts. So what I do here is that we already converted this data to JSON. We already did that part. Now we can give specific conditions. Here I'm creating two different conditions. One being is that for index data, I'm saying that the status code, if it's 404 or n or status code equals 500. But if I want to, I could write many different expressions here so that the filtering is done in a different fashion. But there is pretty much no limit to what you can enter here. And then if it was a simple task, you could have done it with a regex parse, regex filter. But in this case, I gave a condition like this. And in the second part, I give another condition, which is if the act equals close, I will be sending it to a different destination. Also, you can click the unmatched box where if you don't want to send all of the data, if you don't want to lose any data, because if it's not matched the filters, you can create the unmatched, you can check the unmatched flag, and this would create another substream. Now I'm selecting a black hole for it so that it's basically gone to garbage, but you can configure these however you want. On the bottom left, I connected my AVS S3 directly to the source because we want the raw data to be sent to the S3. Right now, I'm configuring a throttling. This is for like throttling, obviously. You set an event limit, you set a threshold, and you can exclude some logs if you don't want them to get into throttling. If they are important to you, you can exclude those. And also, you can split these logs into many different substreams, and then you can throttle some substreams and then don't throttle some of them. Like you can really limit your licensing cost, and you can always prioritize your important logs to be sent even there is like a abnormal situation of log increase. You can always prioritize your important logs by this methodology. And I also implemented a masking function here. So you can also see it create the version one. Right now, I will be creating a worker for this. In this worker section, you basically enter a name, and then if you want to group these workers, you can create a site for them. And on the bottom, you see some different options of deployment like Docker, Amazon EKS, and then OpenShift, Kubernetes. These are our different deployment models. And according to which deployment model you choose, you can enter additional configuration parameters, like if it's going to be if there's going to be auto scaling and if there's going to be load balancing, you can select those parameters accordingly. So here I just selected Docker because it will be a VM deployment, and after we save, it will give us a Git URL because we use the GitOps processes. With the GitOps processes, what I have to do at this point is that take this URL, and after I deploy my worker to wherever I want, if there's connection, we don't do it just by GitHub. We can also do it for on-premise. We can also do it with GitLab and etc. to use our GitOps processes because it's the safest way. We can. At this point, what you would have to do is select this Git URL, copy it, and put it into the worker configuration, and everything is ready. And if it was on Kubernetes, we would also create Helm parameters and other things according to it. But if it's a Docker at this point. Moving on to our next use case, which is live view and reduce, which are a problem explaining before because of the those situations. Sorry about that again. Here on the left, you see our source, okay? And then what we will do is we will add a count value to this source while we parsing it. If there's a receive byte and send byte field inside this log, we will add a count field to it, which is basically in the first part, it will be 1, because after in the reduce part, we would like to add these logs and add these count numbers so the user can see how many data is being merged in the single log they're looking at. And how we do it, this is that like we put a period where the merging will happen. And if you say 30 seconds, and on the below part, you see the group by function. And according to these conditions, if these fields are same for incoming logs for 30 seconds, we will add their receive byte, send byte, and count values together, and we will be sending them as a single event, the grouped ones. If these are not the same for incoming logs, then we don't group it and just send it as it is and keep the count value. Even if you don't want to send it as a parsed way, you can also convert it back to the format it was coming. And to be able to see what I've been just trying to explain is that you can do live view by giving a duration and the worker. We start collecting the data, and then after 80 seconds, we will be able to see on each function how the log is being modified, how it's transformed, etc. So let me fast forward a bit. Here, the log is coming. On the source, we can see it's just like after the message field, obviously, we can also, where the log is coming from, we can see how the native log is coming. And then on the moving parts, on the count function, we can see the count value is 1 here. And then on the reduce part, we will be able to see that the logs are grouped and the reduce count is increasing. In production, we saw like 1,000 counts here, as 1,000, more than 1,000 as values in count field. We saw like 4,000 even for 30 seconds. So it really depends how you want to use it, but it can be really beneficial for reducing the log volume and your EPS so that you have less to pay to your SIM solution. And then in the end, you can see the last part where it's back to the normal format. And this is basically pretty much it. And on the monitoring part, we can also see there's a latency of 30 seconds because we grouped it for 30 seconds. I also want to take questions, so that's why I'm fast forwarding a bit. We have 2 more use cases. First being is replay. We're gonna be selecting and we will be selecting objects, and then we will be replaying them and sending to the destination that we want. Here you can see the key prefix function at work, like it's divided into different logs. Here I just select the objects I want and then replay them. I select the pipeline because it's going to be replayed according to this pipeline's configuration. And then when I start the replay, it will be starting. And when it's, this is not like working always our agent keeps track of the, like, if the user wants to rehydrate any data, and when the user wants, it will open a worker, ingest the data, send it to the destination, and then it will basically close itself. Here at the end, we see the status still running, and then in the end, or after a while, we will see the state being done. So the data is reached to its destination. And our last use case is the RBAC and audit logging and the version control working together. Here, I'm creating, I already create the user, the demo user here. And the demo user will be, and we will implement like RBAC to this demo user. Here you can see what this user been up to. Like you can keep track of when it's logged in, what are the activities of him or her, and then we can also see them in more detail, which I will display later. But we're going to be assigning some authority groups and authority functions so that this user doesn't have the right to reach and like manage everything. You can limit them based on pipelines, based on different functions. Basically, any button in our application can be an authority, and then you group those buttons, and then this will be a authority group, and then you match the authority group with a user group so that those users can only access where the admins let them. Sorry, there was a problem. Moving on, we are selecting our which user group will be having which authority groups, and then when we match them and log in with our demo user and make a change on a pipeline, we will be able to see who changed the version in a given time. So I already recorded this obviously, but I'm going to be selecting a pipeline and then just like changing some random stuff, and then I will be able to see that the version already changed. And also when I log in with the, I can also like take the move back to the previous version. But what I will do is that I will re-log in with my admin user so that we can keep track of what this user has been up to. This pretty much sums up my presentation, and I would like to hear any questions that you have.
Thank you, Yalım. I am just checking the questions. So maybe first question, how does the solution scale in high volume environment? That can be the number one.
Okay. Sorry. Can you close your mic?
Yeah.
Because it's crazy. All right. So how we scale is that the obvious answer is Kubernetes. We can deploy to Kubernetes, and it would auto scale according to the incoming logs and based on CPU consumption, etc. You can set parameters like if the CPU consumption passes some threshold, open new pods, those kind of stuff. And also, if it was a VM deployment, then what we would do is that like we have our own load balancing solution to distribute the load. But also at some point, like if the log is too huge, we ask for a load balancer from the customer so we can deploy our solution to different VMs and distribute the load to them. But in a single VM, we can go up to 2000 EPS per second, and then, no, not 2000, 200,000 EPS. We can go up to those numbers with 16 CPUs, basically. Yeah.
Thank you, Yalım. Thank you, Yalım. Is it better, I think, the voice? So another question is, can we monitor the volume of source logs in the telemetry infrastructure and track how much we reduce them?
Of course, we can track them. We can track them from the EPS count, like in second basis. You can keep track of how many events are coming in real time, and also you can look from a wider perspective, like for, let's say, you want to see for 1 year how much data has been reduced, how much less you've been paying. Basically, you can get these from our report and monitoring screens. And like if in detail, if someone wants to see these in detail, we can always do a special session if required. Mm-hmm.
Thank you, Yalam. I am just checking if we have any more. Alican, did you see anything other than my questions? I think no. Let's wait a few more seconds. Maybe while we are waiting, so as we send the message, we have all the materials here, and also we will be sending email including the recorded link about the webinar as well. So I think we don't have more questions, and we can wrap up. Okay, many thanks for your attendance. Thank you, Yalam. So it was a kind of long journey today for you as well. And thank you for your time, and also hope to see you again in our next webinar. Thank you very much.
Thank you for listening.